Alright, this video is about how to prove whether or not triangles are similar. So to make a long story short, over on the right side of the screen, I've listed the three ways that you know whether or not triangles are similar to each other. So there's not as many of these to memorize as was the case when we were dealing with congruent triangles. So SSS means side, side, side. Now, of course, this does not mean that you have three pairs of congruent sides in the triangles. With similar sides, they have to be in the same proportion. And then we have SAS. This means that you have two pairs of sides in the same proportion and the angle between them being equal. And then finally, AA means that you have two angle pairs that are congruent to each other. Now, the reason AA works is in a triangle, since there are only three angles, if you have two angle pairs the same, well, that means the third angle pair has to be the same. So you have two triangles where all three angle pairs are congruent. That means the triangles are similar. Okay, so let's look at this picture. We have this small triangle, we have a large triangle. So we can tell immediately that both triangles share angle U. So they have one angle in common, but unfortunately that's all I know. We don't know that these two lines are parallel to each other, at least not yet. So we can't say, what you might want to say that is just looking at the diagram, well, it looks like these two angles are corresponding, which would make them congruent, but since we don't know that the lines are parallel, we can't say that. So the only information that we have is about this single angle. So if these two triangles are similar, it's going to be because of SAS. So now let's look at the sides. Here they're doing a very common geometry trick. We need to know this entire side. They gave us the two pieces, so we have to add those together. This long side is 35. So in the two triangles, we're going to compare corresponding sides to see if they're in the same proportion. So let's start with this side on the bottom, and we'll compare it to this side on the bottom. So we're going to compare 77 to 55. Write that as a fraction. And we want to know, or what we're asking is, are these two sides in the same proportion as the other two sides? So we'll take the longer side to the right, and we're going to compare that to the shorter side on the right. So we're going to compare 35 to 25. So we're just asking, is this equation true? If it is, these two triangles will be similar by SAS. Now, if the numbers were really bad, you could just type the fractions into a calculator to see if you get the same thing. These aren't that bad. Here, both numbers are multiples of 11, so we can say 7 over 5. Here, both numbers are multiples of 5. 35 divided by 5 is 7. 25 divided by 5 is 5. So, yep, we have two side pairs in the same proportion, and we have the angle between them. That means the two triangles are similar by SAS. So, we have to finish the similarity statement. This tilde symbol is the symbol for similarity. So we have triangle UVW, UVW, that's the larger triangle. So that's going to be similar to, well, angle U is the angle in common, so that's where we're going to start. And then from U to V was across the bottom, so we're going to do the same thing. We're going to go U, G, and then by process of elimination, go to H. So that's how you can tell if two triangles are similar by SAS. So now let's do another example. So we want to know if these two triangles are congruent to each other. They have this angle pair in common that's given in the diagram, and we can tell that these two angles are congruent because those are vertical angles, if you remember the vocabulary. And then we're done. These two triangles are similar because of angle. And the idea is if the two angle pairs marked are congruent, you automatically know that the third pair is, because angles in a triangle have to add up to 180. They already have 2 in common, so they must have the third one in common as well. So to finish the similarity statement, on the left we started with angle J. That's the vertical angle, so we're going to start in the same place at J. Let's see, then we went to K. That's the angle with 1 mark, so that corresponds to B, the angle with 1 mark. L, that was the unlabeled angle that I marked with green, so that corresponds to C. So angle, that's a really simple similarity postulate to deal with. Let's do one more. You could probably guess what the answer is going to be. So we have no information about the angles. All we have to do is compare the corresponding sides. So what you do here, let's pick the smallest side in the top triangle. We'll have to compare that to the smallest side in the other. So we're going to compare 42 to 12. And now let's go to, let's say, the middle side. That's 77. So the middle side here is 22. So we're going to compare 77 to 22. And then finally, compare the largest side, 84, to the largest side, 24. So what you're doing is you're asking, are the 3 fractions that you see here the same? I'll spoil the surprise. You guys don't want to watch me reduce a bunch of fractions. They are. If you reduce all these 3 fractions, you'll get the same thing all 3 times. So that means the triangles are similar by SSS. Remember, if the numbers are too bad, just type them into a calculator. And then finally, to finish the similarity statement. So the first triangle started with side DE. Okay, well that's D to E. That's the middle side. Okay, so the middle side here, we color-coded these. We're going to do the same thing. Now be careful, you could go DL, but you could also go LD. So let's make sure we're going to get this correct. If we go DEF, D to E is the middle side, E to F is the short side. So let's see, should we start at L? Well, L to D, that's the middle. Well, now we're stuck over here, we'd have to go across the long side. So no, we're going to start at D, we're going to go to L, that's across the middle side, and then we'll go across the short side to K. So that's the how you determine whether or not triangles are similar. Hope that helped.